I would want to know. If I woke up tomorrow and found out this whole universe was a simulation, I would not spend 5 minutes mourning it. I would spend 5 minutes finding the nearest microphone, and then I would start yelling at the ceiling. Somebody built this thing. Somebody made choices, and I have complaints. Let's start there, because it's the question everybody actually wants answered before we get to anything else. Would you want to know if you were living inside a simulation? My answer is yes. Completely, unconditionally yes. And I want to explain why that answer matters more than it sounds like it does, because underneath the joke is one of the oldest and most serious questions in the history of human thought. Is the universe fundamentally knowable, or is some of it permanently, structurally off limits to us? There was a time, not that long ago, when doctors would look a dying man in the eye and tell him he was going to be fine. That was standard practice. Comforting lies were considered a kindness, a mercy, the responsible thing to do for a frightened patient and his family. We don't do that anymore, and the reason we don't is because we decided, as a species, that the truth, however brutal, is worth more than the temporary comfort of not having it. Medicine changed. Ethics changed. The entire relationship between doctor and patient changed, because we concluded that a person deserves to know what is actually happening to their own body, even when the answer is unbearable. If I would want that from my doctor, I would want it from the architecture of reality itself. Lie to me about my prognosis? Fine. That's between me and one physician, and it only affects me. Lie to me about the nature of existence, and you've lied to everybody who ever lived, everybody who ever will live, and every discovery anyone has ever made rests on a foundation that was never real to begin with. I don't accept that trade. I want the truth because the truth is the only thing you can actually build something on. Comfort you can't build on. Comfort just sits there, quietly, until the day it collapses under its own weight, and by then it's usually too late to do anything useful with what you find underneath it. So yes, I want to know. And if it turns out to be true, I have a list of questions for whoever is running this thing, and the first one is, who approved this body? I'm not talking about anyone specific. I'm talking about the general design philosophy of a species that gets lower back pain from sleeping wrong, that pulls a muscle putting on a sock, that requires 8 hours of complete unconsciousness every single day just to keep functioning. You had infinite rendering budget. Infinite. And this is what you shipped. Acid reflux. Wisdom teeth that don't fit. A lower back that fails at 40 because we're still walking around on a skeleton that was optimized for something closer to a chimpanzee's daily schedule. But here's where it gets interesting, because underneath the joke is a real question, and it's a question about whether the universe is knowable at all, whether there's a there, some coherent set of rules underneath everything, or whether it's just noise dressed up to look like order. And that question is not new. It's arguably the oldest question in science, and we've actually already run this experiment once before, a few hundred years ago, and the results should make you cautiously optimistic about everything that follows. Before Isaac Newton, people looked up at the night sky and watched the planets wander against the background stars in these strange, looping, backward paths that nobody could explain with any consistency. Mars would move forward against the stars for months, then appear to slow, stop, and drift backward for a while before resuming its forward path. A phenomenon we now call retrograde motion, and one that terrified and fascinated ancient astronomers in roughly equal measure. And that confusion was fine, culturally, because the sky was considered the domain of God, the one part of creation that was permitted to remain a mystery. Who were you to think you could understand the mind of God well enough to predict where a planet would sit on a Tuesday in March 4 years from now? And then a man sits down with a pen, some geometry, and an obsession that bordered on the pathological, and he writes 3 equations. 3. And suddenly the wandering stops looking like mystery and starts looking like mechanics, like something you could calculate on paper before it happened and then go outside and confirm with your own eyes. Newton got accused of blasphemy for that. Not everyone was thrilled that a physicist had walked into territory that was supposed to belong exclusively to theology and found out it followed rules just as clean and predictable as anything else in nature. People were angry that he'd trespassed. That's the pattern, and it repeats with almost boring regularity throughout history. Every single time someone has said this part of reality will never make sense to us, it's simply too strange, too distant, too sacred. A few generations later somebody proves them catastrophically, embarrassingly wrong. Lightning was divine punishment until Benjamin Franklin flew a kite in a storm and showed it was just electricity moving through the air. Disease was a curse or a punishment for sin until germ theory showed it was bacteria and viruses, invisible but mechanical, following rules you could interrupt with soap and clean water. Every closed door in the history of science has, eventually, turned out to have been unlocked the entire time. Nobody just bothered to try the handle. So if you ask me what I'd want to know from whoever built this simulation, assuming that's what it is, I wouldn't waste the opportunity asking them to fix my knees. I'd ask them one thing. Is every part of this universe knowable through law, or is some fraction of it just noise you never bothered to finish coding? A corner of the map you left blank because you got bored or ran out of time? Because that answer changes everything about what science even is, and whether it's worth doing at all. Science only works, only has any value whatsoever, because what I learn about a falling apple in my backyard also applies to a planet orbiting a star 400 light years away that no human being will ever visit. That is not an assumption we take on faith. That's a measurement. We've checked. Repeatedly. Across the electromagnetic spectrum, across billions of years of cosmic time, across every corner of the observable universe, we've managed to point a telescope at. The same physics that describes a dropped pen on this desk describes the collapse of a star 40 times heavier than our sun, 3,000 light years away, in a galaxy whose light left it before humans had invented writing. If that stopped being true, if the rules over there had nothing whatsoever to do with the rules over here, the entire profession of science would just quietly stop meaning anything. Every physics textbook ever printed would become historical fiction. Now hold that thought, because I want to show you exactly how far this idea of testing whether unknowable things are actually just not yet known has already gotten us, using something a lot of you have already seen without realizing what you were looking at, sitting in a movie theater, eating popcorn. If you've seen the film Interstellar, you know the scene. The crew lands on a planet close to a colossal black hole, huge waves rolling endlessly across a shallow, planet-wide ocean, and every hour they spend down there costs the crew member waiting in orbit roughly 7 years. People ask me constantly, if that orbiting crew member pointed a telescope down at the planet, would they see their friends aging in fast forward, like some horrifying nature documentary running at 10 times normal speed? And the answer is almost the exact opposite of what people expect. They would see the opposite. Looking down toward the black hole, everything would appear to be moving in slow motion. The planet crew stretched out, drawn thin across time, each of their seconds taking years to arrive at the ship. And it's not because the light is doing anything strange or distorting to the picture itself. It's because time is genuinely passing at a different rate down there, and light can only carry that rate faithfully upward to the observer. It can't fix it, speed it up, or hide it. The messenger isn't lying. The clock it's reporting from really is running slower. Think of it as a lighthouse instead of a telescope, because that image makes the mechanism much clearer. Imagine the crew on the planet agrees to send up one flash of light every second, according to their own wristwatches, their own lived experience of time passing normally, the way it always has for them. Because they're deep in a gravitational well, and time runs slower for them relative to their friends safely in orbit, those flashes don't arrive up top every second. They arrive every 2 or 3 seconds, stretched out, delayed, spread thin. Even though down on the surface, by the crew's own subjective experience, absolutely nothing feels unusual at all. That's the whole trick, and it's worth sitting with for a moment because it genuinely defies intuition. It's not that the picture gets blurry, degraded, or hard to make out. It's that the ticking itself changes speed depending on where you're standing in the gravitational field, and there's no version of now that both observers share. And this isn't science fiction politeness dressed up for a movie plot to make Christopher Nolan's math work. This is measured, verified, running in the background of your life at this very moment. The GPS satellite orbiting above your head is further from the center of the Earth than you are standing on the surface, which means According to general relativity, time runs very slightly faster for it than it does for you. Meanwhile, according to special relativity, its high orbital speed slows its clock down slightly relative to yours. The two effects don't cancel. The gravitational effect wins, and the satellite's clock runs faster overall by about 30 microseconds per day. That sounds negligible, laughably small, until you realize that if engineers hadn't corrected for that using Einstein's own equations, your GPS position on the ground would drift by roughly 6 miles every single day. Not a hypothetical. Not a thought experiment confined to a whiteboard. A real correction, coded into satellite firmware, applied every day, because reality actually behaves exactly the way the theory predicts it should, down to the microsecond. Here's the part that should genuinely unsettle you a little, the part that took physicists themselves decades to fully accept. There is no such thing as a single shared now for the whole universe. You are a prisoner of your own present, forever caught between a past you can't reach anymore and a future you can't see yet. And that is the totality of what you actually have access to, no matter how badly you want more. Meanwhile, there are other timelines, other clocks, other people, other planets, other spacecraft, ticking at their own individual pace depending on how fast they're moving through space and how deep they happen to be sitting in a gravitational well. Newton thought time was one universal river, the same current everywhere, carrying everyone downstream at exactly the same speed no matter where they stood in it. Einstein proved that river forks, branches, speeds up and slows down in ways that depend entirely on where you're standing and how you're moving. That was not a small correction to an old idea. That was a complete demolition of what the word now even means. And we've been living inside the wreckage of that demolition, quietly, using it every single day, ever since. So we opened with the idea that the universe might be a lie, a simulation running underneath everything we experience. And now we've shown that even the most basic thing you think you understand, the ticking of a clock, the passage of a single second, is not the fixed, universal fact you assumed it was growing up. If time itself bends and stretches depending on where you stand, doesn't that make the simulation question feel a little less like science fiction speculation and a little more like an open engineering question about the substrate we happen to be running on? Let's go somewhere colder to chase part of that question further, because there's a genuinely clever piece of physics buried here that gets at exactly this. How far does the rulebook actually extend, and does it hold together even at the most extreme edges of temperature and distance we can imagine? Deep space, far from any star, sits at around 3 degrees above absolute zero. The leftover afterglow of the Big Bang itself, cosmic microwave background radiation, still detectable today with sensitive enough instruments, still measurable, still real, a fossil signal from an event that happened nearly 14 billion years ago. At temperatures anywhere near that cold, certain metals stop behaving like a crowd of separate, jostling, independent electrons and start behaving like one single coordinated wave, moving in perfect lockstep. That's superconductivity. Electrical current with absolutely zero resistance, flowing forever in a loop with no external power source, no energy lost to heat, no gradual decay. It's a genuinely strange quantum effect. Cool a material down far enough below its own specific critical temperature, and the individual identity of its electrons dissolves into something collective, something that behaves less like billions of separate particles and more like a single object. The catch is that most actual asteroids floating around our solar system aren't sitting at that theoretical 3 degrees, because they're dark, they're orbiting reasonably close to a star, and starlight is constantly warming their surfaces just enough to keep them well above the threshold most materials need for superconductivity to kick in. You'd need to go somewhere truly, deeply empty. The vast, nearly featureless space between galaxies, not just the comparatively crowded space between planets, to find something cold enough, undisturbed enough by any nearby heat source, to actually cross into that regime. Notice what just happened there. We took a rule discovered in a laboratory, on a lab bench, using equipment built by human hands specifically to test it. And we found out it applies, unmodified, exactly the same way, to a rock floating alone in the void between stars, a rock no human will ever touch or see up close. Same physics. No local exceptions. No footnote saying does not apply beyond Neptune. That's not a coincidence. That's the whole discovery, repeated again in a new setting. The universe does not appear to have local dialects. The grammar holds everywhere we've checked. Now let's bring that same idea home, down to something you physically felt with your own body every single day of your life without ever thinking carefully about the mechanism sitting underneath it, the tide. If the moon vanished tonight, silently, without explanation, the oceans would not go still and flat. You'd still get tides, roughly a third the strength of what you currently experience, because the sun pulls on the ocean too. Just less dramatically than the moon does, since it's so much further away, even though it's vastly more massive. Call it decaf gravity if you like. It's there. It's just weaker, quieter, easier to overlook. But here's the part almost nobody gets right, including, embarrassingly, some very confident popular explanations you'll find repeated online. There's a persistent myth that a full moon somehow supercharges the tides through some kind of special extra lunar energy that only shows up when the disk looks complete and bright in the sky. It doesn't work that way at all. What actually happens is that during a full moon, the sun and the moon line up on opposite sides of the Earth, and the sun's smaller, gentler tidal pull adds directly onto the moon's larger, dominant one, reinforcing it. The exact same thing happens during a new moon, when the sun and moon line up on the same side of the Earth instead. You get equally enormous tides then too, just as high, just as dramatic, except almost nobody notices or talks about it, because you can't see the new moon glowing reassuringly in the night sky the way you can see a bright full one. People are extraordinarily good at noticing what's visible and extraordinarily bad at noticing what isn't, even when the invisible thing is doing exactly as much physical work as the visible one they're busy admiring. So here's the wrong idea, stated plainly now, the one that keeps circling back through every single one of these topics we've covered so far, wearing a slightly different costume each time, that some part of nature is fundamentally exempt from explanation. Too mysterious, too far away, too strange, too intimate, too sacred, to ever be reduced down to mechanism and rule. Distant starlight bending around a black hole, deep space code near absolute zero, an invisible new moon quietly pooling on an ocean nobody's watching, your own memory sitting somewhere inside 3 pounds of tissue behind your eyes. Over and over, in every single case, people assume there's a velvet rope keeping science out of certain rooms, certain topics, certain corners of existence. There isn't. There has never actually been one. Every single time we've checked carefully enough, the rope turns out to be imaginary, decorative, put there by our own discomfort rather than by the universe itself, and the room turns out to have been open the whole time, waiting for someone curious enough to walk in and turn on the lights. I want to be honest with you now about the one place where I genuinely don't have a clean, satisfying answer, because pretending otherwise would make everything else I've told you tonight less trustworthy, not more. A person who claims to have every single answer stops sounding like a scientist and starts sounding like a salesman. So here it is. Black holes destroy things. That much is obvious to anyone who's seen an illustration of one swallowing a star. But there's a decades-long, genuinely unresolved argument in theoretical physics about whether they destroy information in the strict technical sense used by physicists. Whether the complete, detailed, atom-by-atom description of everything that ever fell in is truly, permanently gone forever, erased from the universe with no trace, or whether it's preserved somehow, smuggled back out as the black hole slowly evaporates over almost unimaginably long stretches of cosmic time through a subtle quantum process called Hawking radiation. The leading idea, the one most physicists currently favor, is that the particles boiling off the black hole as it slowly evaporates aren't generated purely at random. They carry an imprint, a kind of deeply scrambled memory of everything that ever fell across the event horizon during the black hole's entire lifetime. That sounds tidy when you say it out loud in a single sentence. Here's exactly where I get genuinely stuck, where the tidiness falls apart under close examination. If something is staggeringly information, rich as a single strand of DNA fell into a black hole, your entire genetic identity, encoded in a molecule, I cannot walk you through, in any concrete, mechanical, step-by-step way, how you would ever actually reconstruct that molecule-specific information from a spray of outgoing radiation that looks nothing whatsoever like a DNA molecule that carries. No obvious resemblance to what fell in. The math, broadly, says the information count on both sides of the process should balance out in the end. I do not currently have a satisfying, concrete mechanical answer for exactly how that reconstruction would actually work in practice, and neither, as far as I can honestly tell you, does anyone else working in the field right now. That's not a comfortable thing to admit after spending this much time insisting that everything, in principle, is knowable. But knowable in principle, given enough time and cleverness, and known right now, today, by anyone alive, are two very different sentences, and I would rather leave that gap sitting there, open and honestly labeled, than paper over it with a confidence I simply don't possess. Zoom out now, away from black holes entirely, because there's a similar illusion sitting quietly at the very largest scale of the universe that's worth clearing up carefully before we land this whole conversation. Galaxies are not scattered evenly through space, like sprinkles distributed carefully across the surface of a cake by a careful hand. They clump together into vast, sprawling filaments and thin sheets, with enormous, nearly empty voids stretching between them. A structure astronomers call the cosmic web, though if you actually look at a three-dimensional map of it, it looks considerably less like a spider's delicate, symmetrical web, and considerably more like a thick sponge sliced cleanly in half, all connected fiber strands running through mostly hollow gaps. People sometimes look at that structure and assume it must imply some kind of underlying design, some organizing intelligence, carefully arranging galaxies into place according to a plan. It doesn't need one, and there's no evidence for one. Gravity alone, acting patiently over roughly 13 billion years on tiny, almost imperceptible density fluctuations present in the very early universe. Fluctuations we can actually still see today, frozen into the cosmic microwave background as faint temperature variations, is entirely sufficient, mathematically and observationally, to produce exactly that clumped, uneven, web-like structure we observe today. It looks organized, deliberate, almost architectural, because gravity is extraordinarily patient and perfectly consistent over enormous stretches of time, not because anyone, anywhere, was steering the process toward a particular outcome. And that brings us, finally, all the way back around to the question that started all of this tonight, except now you're standing on completely different ground than you were when we began. People ask whether consciousness, memory, love, grief, the very specific, particular feeling of being you rather than someone else, is really just atoms, as though naming the underlying mechanism somehow cheapens or diminishes the experience itself, drains the meaning out of it. Here's what we actually, concretely know, based on decades of clinical and experimental evidence, not speculation. Thought moves through your brain as electrochemical signals firing across the tiny gaps between individual neurons, gaps called synapses, at speeds and patterns we can now measure directly with electrodes and imaging equipment. We know this with real confidence because when illness or injury damages specific regions of the brain, a stroke, for instance, cutting off blood flow and oxygen to one particular area, very specific, predictable pieces of a person's identity fade away, depending entirely on exactly which region was affected and how severely. Facial recognition can vanish while speech remains perfectly intact. The ability to form brand new memories can disappear entirely while decades-old memories, apparently stored differently, in a different physical location or through a different mechanism, remain sharp, vivid, and completely undamaged by the same stroke that erased everything from yesterday. That's not a philosophical claim dressed up to sound scientific. That's a documented, repeatable, well-studied clinical pattern observed in hospitals around the world every single day. It tells you plainly, unambiguously, that what you casually call yourself is built entirely from physical processes that can be selectively, precisely damaged, piece by piece, almost like a house slowly losing individual rooms one at a time during a long, patient storm, while other rooms remain completely untouched. So here is the reversal I promised you back at the very start of all this. The one thing I wanted you to walk away holding on to. The wrong idea running through this entire conversation was never really specifically about simulations, or black holes, or ocean tides, or fading memory. It was the exact same idea wearing 5 completely different disguises, appearing again and again dressed up in new clothes. That somewhere, in some corner of existence, there's a door marked "Do Not Open," unknowable by design, permanently off limits. There isn't. There has never been such a door anywhere we've actually looked hard enough. Every single time humanity has found one of those signs nailed firmly to a locked door in reality and decided to check behind it anyway, out of stubbornness or curiosity or simple refusal to accept the label, the sign has turned out to be a bluff. And what waited quietly on the other side wasn't chance, wasn't randomness, wasn't divine mystery meant to remain forever unsolved. It was mechanism. Patient, consistent mechanism, all the way down, waiting the entire time for someone curious enough to actually knock. If you still want to believe there's a room somewhere that science can never enter, a question that will remain permanently unanswerable no matter how long we look, ask yourself honestly whether you've actually found a genuinely locked door, or whether, like almost everyone before you, you've simply never bothered to try the handle. Keep looking up.